All right, in this video, we're going to take a look at rates of change that do not involve position, velocity, acceleration. And what you'll notice is that the context, even though they're not exactly the same as position, velocity, acceleration, there's always like analogs you can draw. So, for instance, this has this says Q of t equals this function. It gives the number of gallons of water in a tank at t minutes. So right away, I noticed that that's similar to position, right? That the quantity there we're given is a quantity that's analogous to position. And the first thing we're asked to find is a rate of change. It says find the rate at which the water is draining in gallons per minute at t equals 3. So we're asked for a rate of change at an instant, which means we need a derivative. So before I do that, I'm not going to assume you know the chain rule if you're at this video, which means in order to take this derivative, we have to expand a little bit and then use the power rule. So if you expand 10 minus t squared, you get 100 minus 20t plus t squared, and then we distribute, and we get 20,000 minus 4,000 t plus 200 t squared. So now we can use the power rule, going term by term. The derivative of 20,000 is 0. The derivative of negative 4,000 t is negative 4,000. And the derivative of 200t squared is 400t. And so now we evaluate this at t equals 3. And so we get negative 4,000 plus 400 times 3, which is negative 4,000 plus 1,200. So that's negative 2,800 gallons per minute. Shot up to where I did this problem earlier. The one thing I want to point out is let's be careful how we answer this question, because the word draining is implying that it's taking care of the verbal description is taking care of the negative there. So let's just answer the question as a sentence, like assuming you were taking a test and you didn't want to get this wrong. So we can say that the tank, or the water is draining at a rate of 2,800 gallons per minute at t equals 3. So the word draining is taking care of the fact that the rate of change is negative. Okay, it would be awkward to say it's draining at negative 2,800 gallons per minute, because it kind of implies a double negative there. Okay, what about part B? It says to find the average rate of draining from t equals 5 to t equals 7. So an average rate of draining would be an average rate of change. That's not a derivative, it's the slope of a secant line. So the average rate of change of it's the average rate of change of our function on the interval 5 to 7. That's what we want. So that's going to equal q of 7 minus q of 5 divided by 7 minus 5. This is analogous to a velocity, because you have a change in gallons, or a change in a quantity, which is gallons, and you're dividing it by a change in time, which is in minutes. So that you can see that's analogous to sort of like velocity in this type of problem. But in any case, so q of 7 would be 10 minus 7 is 3. 3 squared is 9, so it's 1,800. And then 10 minus 5 is 5. 5 squared is 25 times 200 is 5,000 divided by 7 minus 5, which is 2. And so that gives us, I'm going to just do it to break this up. So it's 1,800 divided by 2 is 900 minus 2,500. And that gives you negative 1,600 gallons per minute. Okay, so and then and then maybe just to put it in a sentence in a way that would give us full credit. Um, let's say on the time interval, on the interval 5 to 7, the average rate of draining is 1,600 gallons per minute. And again, bearing in mind the word draining is taking care of that negative we see right here. A negative rate of change obviously makes sense in this problem because it's losing water. But when you start to craft a sentence, you want to make sure that that it actually makes sense and you're not putting in some double negatives. So that was just an example of rates of change that don't involve position, velocity, acceleration.